Hi, this is Anagha Mudgal. Welcome back to the channel. In this episode, we will explore the Relight module in DaVinci Resolve. But before we dive right into it, let's understand how relighting is done traditionally in CGI. So, here in Blender, we have set up this scene. We have created models representing traditional Bankura clay toys, which are made from terracotta. So these are the diffuse maps, and these are their normal maps. We're going to output the beauty pass. We're also going to output the normal pass and the Z-depth pass. Let's hit render. Now let me explain what a normal map is. It is a form of height map and a bump map that stores the surface direction, normal, which can be used to control and store the texture information to simulate the appearance of surface details such as bumps, scratches, wrinkles, and more. You can see these blue lines protruding in a perpendicular direction from the surface, and this direction, which is also known as vector, relative to the surface is called the surface normal or simply a normal. The vector points towards a direction. Anywhere it points is where the light reflects. And as you can see, as we are changing the geometry from a simple cube to an octagon to a monkey, the normal direction changes according to the curve. The normal map encodes this data in RGB, in red, green, blue image format. As Fusion is a channel-based compositor, it uses red, green, blue normal information embedded within the image, which can be used to relight the image. So, let's shift to Fusion. So these are the maps we have rendered out. This is the beauty pass and this is the normal pass. So the first thing we are going to do is map the individual X, Y and Z normal pass to X normal, Y normal and Z normal channels. We're going to add channel booleans. Channel booleans are used in image processing to manipulate different components or channels of an image such as red, green, blue, RGB channels or alpha transparency channels. It applies a variety of mathematical and logical operations on the channel of an image. You can take the channel of one image to modify the channel of another image. So let's select auxiliary and then enable extra channels, and we're going to add these X, Y, Z normal channels. In the X normal, we'll select red foreground. In the Y normal, we'll select green foreground, and in the Z normal, we'll select blue foreground. Let's check normal X, and it appears to be correct. It is lighting from the right. The normal Y is lighting from the back, and the normal Z is lighting from the top, which is incorrect. Fusion wants the normal Y should light from the top, and normal Z should light from the front. Now why is this happening? Because the coordinate system in Blender is set such that the X-axis is colored red and moves side to side. The Y-axis, which is colored green, moves forward and backward, and the Z-axis, which is colored blue, moves up and down. While in Fusion, the X-axis colored red also moves side to side. The green, which is the Y-axis on the other hand, moves up and down, and the blue axis, which is the Z-axis, moves forward and backwards. Now, coming back. To correct this, let's go back to our channel boolean and switch the Y normal to blue and Z normal to green. Now this is showing the correct configuration. Let's check again. We have the normal X, which was already correct, and normal Y, which is now coming from the top, and normal Z, which is coming from the back. Now while the Z normal is in the correct direction, it is still not accurate because the Z normal should light from the front along the positive axis. To correct this, we will use a custom tool. The custom tool node is the most complex and most powerful node in Fusion. It is used to create custom expressions and filters to modify an image. In the custom tool, we will go to channels, and these are the expression names assigned to these channels. In the blue channel, we will set this to -B1, which will flip the blue towards the front. Then we will go to the auxiliary channel expressions, where we will set the Z normal to -NZ1, flipping the normals to the front. Now, explaining custom tool will take a complete video all on its own, but for now, just know that to correct our normal pass or even position pass, just add minus to the blue channel and Z normal channel. We have the normal Z lighting from the front, normal Y lighting from the top, and normal X lighting from the right. And in the normals, we can see the right colors that a normal should look like. Now, let's create our lighting. The traditional method of relighting is to use a tool called shader node. The shader node enhances the realism of rendered images by controlling lighting, reflection mapping, and 3D shading. But it requires specific data, which is the normal map channels, to function, without which this node has no effect. So let's right click and go to Add Tools, Deep Pixel, and choose Shader. Now let's connect our custom tool to shader node. In shader node, we can see these various lights and colors which we do not want. So we will remove the diffuse and ambient, since we want only a black and white image to create a sort of mask for our relighting. The only elements we will use are the equator angle and the polar height. As we rotate the equator angle, we can see our lights rotating. And moving the polar height, adjust the light vertically. And we will only use these two tools to relight the scene from this side. So we need to connect this to our original beauty pass. We're going to use a brightness contrast node, connect the beauty pass with this node, and we're going to increase the gain to about 4.5. And now we're going to connect the shader node to the brightness contrast. Before that, we're going to load a bitmap node, which basically enables us to use the image from the node tree to act as a mask for other nodes and effects. So, go to Add Tool, Mask, and select Bitmap Mask. And connect the shader to the bitmap mask. And in the bitmap, in the channel, we're going to change from alpha and select the luminance channel to create the mask. Then we will feed the bitmap into the brightness contrast node. And now we can see that there is light in our scene. So we have relit the scene from this side. Now, we can also add colored lights to the scene. So, let's add a color corrector. And we're going to connect the brightness contrast to the color corrector. And let us shift it towards blue. Since this is warm, let's add some cool lighting to our scene. Now, let's duplicate the shader node and the bitmap mask as well. So, let's connect the bitmap mask to the color corrector. And we can see the blue light incorporated in our scene. Now, let's return to the shader node. And if we rotate the equator angle, we can see that our blue light is moving, allowing us to relight our scene. So, this is how we relight in Fusion using the shader node. Now we will explore relighting the scene using Relight node in Fusion. Okay, so the first thing we're going to do is copy these nodes over to that side. So this is our beauty pass and this is our corrected normal pass. Now, let's add the Relight node. So shift space and type Relight. You can also find this node under the matte section. We will connect the beauty pass to the Relight node and the custom tool to the Relight node as well. So let's load it. On the left we have the Relight and on the right we have our beauty pass. Now Relight node is highly computational intensive. It uses a self-generated surface map. And by default, this is set at point source, which means it's emitting light from a point, like a candle or a light bulb. When we click on the sun icon or the red emitter, we can drag it around to relight our scene, and this to affect its reach. We can use the directional to create distant source of light, such as the sun or a moon, and then we have the spotlight, which functions like a point source but with a more concentrated beam, similar to a flashlight. As mentioned, this is currently using the self-generated surface map, but we are going to use the normal map that we rendered from Blender. So in the Relight node, we'll go to the surface map and change the input to use normal input. And in the external map section, we'll enable Rescale Oversaturated, which is going to rescale our overly saturated map and help the program interpret the colors correctly. So now we have this smooth looking effect. And now as we move around, we can see that the scene is being lit. So let's increase the brightness to around 5. Now it's a bit bright, but we can control both the angle of the beam and the brightness of the light. Next, let's create another brightness contrast node. We'll create a bitmap mask for this light and connect it. Let's also connect the beauty pass with the brightness contrast. In the bitmap mask, we will select the luminance channel. And in the brightness contrast, we're going to increase the gain. We're going too extreme, but it's only to demonstrate the different lighting setup and how the Relight node interacts with an external normal map. So currently we have the spotlight selected. And now let's check point light. And let's go back to the brightness contrast node, and I'll reduce the gain to 5 because it's getting too bright. So currently the point light is lighting from above. If we select the reinterpret up down, which is going to switch the direction of the light. In this project, we'll be using the directional lights to light our scene. So it's currently too bright, so let's reduce the intensity. And we're going to keep it on this side. Now we want to use the directional light as a fill light. Let's duplicate this to relight the left edge area and create a rim light. Let's load the second brightness and contrast node in the viewport. Let's uncheck reinterpret up down, and I'll set the direction of the light. And now this scene is beautifully lit. So this was before the Relight node, and this is with the relighting. And this is how we use Relight node to relight a scene in Fusion. Now we're going to use the same Relight node to relight a scene without normal map in DaVinci Resolve color page. So here we are in DaVinci color page, and we have a clip loaded. What we're going to do is turn this clip into an evening shot and then relight it using the Relight node. So let's get started. I'm really going to reduce and crush the shadows here, but we want a nice background look as if the night is about to set in. And I'll pull the midtones down a bit and maybe just lift this slightly. Okay, now let's add the Relight node and add it in the node tree. And as soon as we connect it, a surface map is generated. And we can see this red emitter icon. If you don't see this, so make sure that your main viewer's mode is set to Open FX overlay. Now as I move this light, there's some lag. It's not as smooth as we'd like. This is because the Relight node is computationally intensive. It requires a lot of GPU power. It analyzes the image and creates a surface map. And when we change the light's position, it has to redo the analysis, which makes it slower to work with. To improve performance, we're going to enable Output Surface Map. This will turn off all other features in the node, keeping only the pre-analyzed surface map. And we have an extra option to control blanking issues like letterboxing and pillar boxing. Now, we can see the normals generated over here. Let's rename this node to Surface Map. Next, we'll add another Relight node in the node tree. Let's connect the output of the surface map node to the second input of this Relight node and connect our primary graded node output to the first input. In the surface map settings, we'll switch from Use Internal to Use Input 2. Now, as we move our light, there's no lag. It's using the surface map generated by this node to relight our image, allowing us to make quicker adjustments. Now let's check the other parameters. We have these 3 types of lights to choose from, which we briefly covered before. Currently it's set to point source, meaning it's emitting light from a specific point, like a candle or a light bulb. Now, if we go to the light position section, as we drag this up and down, we can see how it affects the z-axis, dimming or boosting the light. And moving the emitter is going to change the position in x and y axis. Now let's look at directional. This simulates a distant light source such as the sun or moon. And in the light direction, we can see we have the azimuth and the elevation, which is the angle of the light direction in the horizontal axis and how above and below the light source is in the y-axis. Then we have spotlight, which works similarly like a point source, but with a more focused beam, like from a flashlight. So adjusting the X icon sets where the beam is targeted. The emitter and the small circle functions the same as the point source, while the largest circle affects the beam angle. And we can also adjust softness or harshness of the edge. Now, let's switch back to point source and let's go over these other parameters. We have brightness, which doesn't brighten things on its own, but boosts any grading adjustment made on this node. So keep in mind that all these parameters will also affect your actual scene. Next is reach, which controls how much light fades as they get further from the light source. Contrast determines how sharp or smooth the transition is between the light and the dark areas. Now for surface properties. Adding glossiness creates a sort of shiny highlights on surfaces, giving them a sort of metallic shine. Specularity controls how glossy or shiny the surface looks. And shadow softness affects how much light fills in the deepest shadows. Let me increase the specularity a bit so you can see the effect on this side. Now I'll reset this, and I've already explained light position. So now let's come to input surface map. These options are only available when using an externally generated surface map, and they help to ensure that the map looks the way it should and interacts correctly with the light. So first we have rescale over saturated. So some surface maps can appear overly saturated. So this will rescale the external maps and help the program interpret the colors correctly. Reinterpret left, right and up, down. These options will help to swap the directions of the surface map if needed. Now let's uncheck relighting map preview. And as we drag this icon around, you may notice nothing is happening. But when we enable the relighting map preview, we can see that light illuminating the scene. Now this is because the details about how light impacts the image are stored in a separate part of the file called alpha channel. This light is only acting as a mask. This channel is meant to work with DaVinci Resolve's color grading tools, so you can make adjustments to it later. So let's raise the gamma values, and now we can see it is affecting the scene. I'll also warm it up a bit from this side. Let's see. Okay, now let's add another relight node to brighten this side. So let's add this node and we'll rename this Relight 1 and we'll call this Relight 2. And I'll connect the output of Relight 1 to the first input of this node and connect it to the final output. And we'll use the same analyzed surface map data of this node for the second input. Now, let's switch this to use input 2. And here we have our second light. Now let's uncheck this and I will make the adjustments. Let's see. And I'll do this. Okay. I'll disable these and we can review the changes. So we can see we've added some glow here and some fill from here. Okay. Now let's play this part. Now we can also keyframe and animate the light. Let's animate this part. Now I'll go back a few frames and add a keyframe. And as the head starts to turn, I'll add another keyframe here. And on this frame, I'll reduce the intensity slightly. And as I scroll through, you can see we've animated the light. Now, I'll add another node to slightly brighten the scene using the curves. And I'll return to this node to reduce the brightness and increase the contrast a bit. And all these parameters can be animated. And you can also use the FX tracker to track the light. So that's our final image. So let's review what we did. We deliberately crushed the scene, added Relight 1 for warmth, and then added Relight 2, and then slightly brightened the scene, and here's the result. And this is enough for demonstration purpose. Now let's take a look at a different example. In this example, we'll use multiple relight effect to illuminate different areas. We can use the power windows, but this does not honor the surface normals or the curvature of the face. So let's use multiple relight nodes for this. First we'll cool this area and then add some warmth to the opposite side and then relight the neck and then the forehead. Let's create the same node tree. And this one will act as our surface map, and this is our first relight node, and we can see the map is working fine. First we'll cool this area, and I'll make these adjustments. Next we'll add another relight node in the node tree. And for the second relight, we will add some warmth to the opposite side, very slightly. Don't worry if it's getting oversaturated, we'll adjust that later. And this is just for your demonstration purpose. Now let's add another relight node and make the same connections. We'll tackle the neck, relighting it just enough to reveal some details. And I'll just reduce the reach. Okay. Next we'll add another relight node in the node tree. And before I proceed, let me just rearrange these nodes. And let's adjust the light to get it just to the forehead. And you can see here it's brightening the forehead slightly. And now let's adjust the overall saturation in a new node and desaturate it a little bit. And that's it. So we can use multiple relight effect. The relight tool honors the curvature of the face, making it slightly more effective than just using power windows. But the downside of this is that it is computationally intensive. I have a good graphic card, so I can use 4 nodes and still get a decent performance. If your GPU isn't so powerful, you can achieve similar result using the power windows. So now, let's try a different clip. This one is from Pixabay, and I'll quickly drag and drop the relight node. Check how the normals are captured. That looks accurate. Let's feed this here and this here. And just brighten the left side a little bit. And that's it. Now additionally, you can also use a power window, magic mask, or even a depth mask to separate some elements in the scene. And if you want to cache the node so that it speeds things up, you can just go to playback, render cache, and switch to smart. And that's it. So, in conclusion, you have to use the relight tool very subtly, just to give that little glow, that little fill or light on your face. It is not a CGI effect. In CGI, you have complete controls, as you have access to the actual normal map. But here it simulates the normal map, following the curvature of the body or face. It's not a true normal map. As we saw in the previous example in Fusion, we could rotate the light around. We don't have that flexibility here. All we have is a pseudo-normal map that limits how we relight our scene. And once we have a mask, we can now darken or brighten specific areas. And this is why it is more of a creative tool. It is called the Relight tool, but I prefer to call it a more creative relighting tool, ideal for creating that warmth, coolness, slight color contrast, adding the fill where it is needed. But just remember that it is computationally intensive. And if you do not have a good GPU, you may run into performance issues with this tool. So, that's all for this episode. For now, bye, take care, and see you next time.